welcome to JCE Connect. Today I'll be discussing on overtaking side distance requirements, factors, and analysis of overtaking side distance on two-way road. Overtaking requirement. So if all vehicles are traveling along a road at a design speed, then theoretically there is no need of any overtaking. But as vehicles are not moving at design speed, then we'll come across slow moving vehicle, fast moving vehicle, and in mixed traffic condition, yes, definitely there is slow moving and fast moving vehicle, and drivers are also free to travel at lower speeds, so there is a need for overtaking of slow moving vehicles. So the definition of this OSD is, it is a minimum distance open to the vision of a driver, that is overtaking vehicle, move safely without colliding with the opposite coming vehicle. So that distance which you can see, so that distance is overtaking side distance or safe passing side distance. Now the requirement, that is the distance measured along the center line of a road, which a driver with his eye level at 1.2 meter above the road surface can see the top of an object or the opposite coming vehicle 1.2 meter above the road surface, especially on a summit curve, which you can see in the diagram. That is, it is difficult to see the opposite coming vehicle even though the vehicle is very near, because of obstruction, convexity of the curve. It is difficult to see the opposite coming vehicle. That's why IRC has specified the height of a driver's eye, that is 1.2 meters. Now factors affecting the OSDs: speed or the velocities of the overtaken vehicle and the opposite coming vehicle. Next is spacing between the vehicles, that is, which in turn depends on the speed, that is distance between the overtaking and overtaken vehicle. Next is skill and reaction time of the driver, how skillful the driver is there, or is a learner, then he will not dare to overtake. He will like to take some more time. He will prefer to go for a much safer opportunities where I will see like there is no opposite coming vehicle, then only I will overtake, or the reaction time of the driver same. Next is rate of acceleration of overtaking vehicle, depends on the type of vehicle, especially if you are traveling in cars like SUVs like Innova or other high-end cars, then definitely rate of acceleration is higher and you will dare to go ahead for overtaking. When it is compared with the rate of acceleration of the vehicle is less, then we'll see much safer opportunities rather than the immediate action. Next is gradient. For up gradient, yes, it is difficult to overtake, and down gradient the vehicle will be moving at a higher rate and much safer is at the level ground. Next is analysis of OSD on a two-way road. In the below diagram, what you can see, that is vehicle A, B and C. So where vehicle A is traveling at a design speed V and desires to overtake the slow moving vehicle, that is vehicle B, slow moving vehicle is B, which is moving at a speed of small VB, and the vehicle A has to wait till he gets an opportunity to overtake the slow moving vehicle B, and then he will accelerate and he will shift to the next lane and he will overtake. that we can see from A2 to A3. So till that opportunity he is moving from A1 to A2 position, that is distance D1 given below, that is small d1. And next you can see that is vehicle C, which is coming in the opposite direction on the next right side lane from C1 position to C2 position. So here you can see D1 is from the overtaking vehicle moving from A1 to A2 position. Then D2, small d2 is the overtaking vehicle is moving from A2 position to A3 position. The total distance is B plus to S, and small d3 is opposite coming vehicle from C1 to C2 position. The same explanation is given here, the initial two slides, the analysis part. And the determination of components, that is small d1 is equal to t, that is reaction time of the driver for overtaking side distance. We are taking that is very instantly will react, so that reaction time is taken as 2 seconds. IRC suggests that is an average upon time is 2 seconds, so it will be 2 into VB. VB is VB is the slow moving vehicle. As your vehicle is moving at the slow moving vehicle speed, so D1 is equal to 2 into VB. Next is D2, as you mentioned, that is B plus 2S, where S is spacing between the vehicles or gap. S is equal to 0.7 VB plus 6 meters. And capital T is overtaking time, which is equal to square root of 4s by a. And a is small a is the rate of acceleration in meter per second square. And d3 equal to v into capital T, where v is design speed of overtaking vehicle and T is overtaking time. If VB is not given, that is in meter per second, VB is equal to V minus 4.5 seconds, and if it is in kmph, so the formulas will slightly change for capital T, and VB is equal to V minus 16 kmph. So total OSD is D1 plus D2 plus D3 if it is two-way, two-lane traffic. If opposite coming, if it is a one-way is there, then D1 plus D2. We are not considering the opposite coming vehicle. So these are the various speeds in kmph and meter per seconds, and similarly acceleration in kilometer per hour per second and meter per second square. Next is overtaking zone. So it is not possible to provide for the entire stretch OSD. So some of the stretches you might have observed, especially in the guard sections, they'll provide, they'll mention that is overtaking zone starts and overtaking zone. A minimum is 3 times the OSD, and desirable is 5 times the OSD. So this is a simple diagram which we need to draw, or it will be like this. That is S1, what we see is the signpost which mentions that is overtaking zone starts, and S2 is before the overtaking zone ends, that is we need to provide a distance of 1 OSD distance that overtaking zone ends, so that the driver should be in his lane. It should be 3 to 5 times the OSD distance. So like this signboards which we see on the roads. The next presentation I will be discussing on problems on OSD. Thank you very much.